Hey there, Physics 1. I have for you a kind of quick experiment today. I'm going to take some different tubes that have elemental vapors in them. So we have helium, hydrogen, neon, mercury, and argon. We're going to apply a voltage to them and observe what happens when the atoms in these vapors are energized. And what we're going to observe is the spectrum of light that's emitted from them. So you're going to see them glow when we apply a voltage to them because we're adding some energy to these electrons. They move up to an excited state and then they drop down to a lower state again. And when they do so, they emit energy. So we're applying a voltage to them, we're energizing the atoms, and then they reduce their energy again by emitting light, by emitting photons. What we're going to look at, though, is what types of photons are emitted, because it turns out we're going to see some distinct wavelengths or distinct colors that are emitted from each of these different atoms. The way we're going to do that is with this, what we would call a diffraction grating. So this is a sheet of plastic that has a refractive index that is designed so that the colors in white light are separated out into distinct colors, and then we can see that happening because it's a thin sheet of plastic. So light refracts or bends when it hits the surface, but red light bends just a little bit differently than green or blue. And as a result, the colors separate out the way they do with a prism. So what we're going to do is I am going to turn out the lights. I'm going to get the hydrogen tube glowing, and you're going to see its color. And then I'm going to put this screen in front of the phone camera so that you can see this distinct colors that are generated when hydrogen is energized. You may have seen this before in chemistry, but I want to talk about it a little bit in relation to physics and in relation to waves and light. So I'm going to run through this demonstration really quick. I'm going to turn out the lights. I'm going to energize these different spectrum tubes, and then I'm also going to have us take a look at some light bulbs. I've got a compact fluorescent light bulb, and I've got an incandescent light bulb, and so maybe you can be thinking about it now, what you're going to see when we look at those through our basically our prism paper or spectroscope. Okay, let me turn out the light. Give me just a second. All right, so this is hydrogen. So we're going to put the filter in front of it, and so you can see those distinct colors appear. And it separates out. All right, I'm going to switch to helium next. All right, so that's helium. Looks very white. And then we put the prism in front of it, and I'm actually going to rotate it a little bit because it seems to separate those colors out so you can see several distinct lines. I think I see about 4 distinct lines here. I think I see a red line, a yellow line, a green line, and a blue line. So you can see those 4 distinct colors present in the helium spectrum. And I'm going to set this down, and I'm going to switch to we'll do mercury next. All right, so that's the mercury tube. And now you can see the spectrum for mercury. Let's see if we bring it a little bit closer. I'm not sure if that helps or not. Hopefully you can see a little bit of red in there, but also some green and blue and purple lines as well. So again, what looks like a single color, we actually can separate into several distinct wavelengths that make up that color. All right, so I can take the mercury out and we'll switch to, let's do neon next. All right, that's our neon tube. This is what neon lights look like. It looks very, very red. And when we put this spectroscope in front of it, hopefully you can see there's actually more than just red in there. They're kind of hard to see, unfortunately, on the video, it looks like. But there are some yellow and also some green lines in there as well, as well a whole bunch of different lines in the red region. Let me just hold this there for another second. Maybe you can see right on the edge of those separated lines, you can see some green, like at least 2 green and 1 yellow line. All right, so there's our neon light once more. And I've got one more spectrum tube for you. I've got argon. This one. Oh, there we go. Got that faint purple color. But you can see that that purple is actually composed of several different colors. You can see some green and red and orange. But there's actually quite a lot of lines for that argon. Hopefully you can see those separated out. Notice, if you remember, with the hydrogen, we only had a couple lines. But now with argon, we actually have quite a lot. I think it'd be difficult for us to count all of those lines, but you can see that they're separated out into different colors. All right, so there's argon again. So we've seen those different spectrum tubes that have a single color present. And the next thing I want to do is take a look at an incandescent light bulb. Or sorry, we'll look at a compact fluorescent light bulb next. This is going to get bright, so it's probably going to look weird on the camera for just a second. There we go. Okay, so there's our compact fluorescent bulb, and I'm going to put the screen in front of it, and hopefully we see some different colors. Now, one thing I want you to notice about this is there's actually several different colors that are distinct colors. There are bands of colors. So you can see the image in red, you can see it in yellow, you can see it in green, and you can see it in blue. With a compact fluorescent bulb, it actually works a lot like those spectrum tubes. We've got a gas that's inside that compact fluorescent that's excited, energized when we apply a voltage to it. And as it's excited, it releases energy in distinct packets, distinct wavelengths. Now, how does this look different from, say, a incandescent light bulb? Well, I can show you that next. So I'm going to shut this light off, and I'm going to swap it out for an incandescent light bulb. Now, you may remember we talked about incandescent light bulbs before and how they work back when we were talking about the circuits, when we were talking about what light bulbs were. This incandescent light bulb works by making a little segment of wire, a resistive segment of wire, very, very, very hot. Okay, so got that bright light now, and I'm going to put this screen in front of it, and hopefully you can tell this is actually quite different. It's actually just a blur, like a rainbow. You can see there's not any distinct patterns or lines. It's like it's that rainbow color smeared out. And that's because the incandescent bulb doesn't have distinct wavelengths or bands. It really glows in all wavelengths of visible light. So you've got, every possible color in that visible spectrum that's present, which is why it's just kind of smeared out in a rainbow instead of having distinct lines like we saw on any of those previous examples. So I'm going to stop here. We will talk about this phenomena a little bit more later, but hopefully this will help you give you a reference for what we mean when we talk about the electromagnetic spectrum and that white light is composed of all of these different colors. Now, I don't know, you may have some sheet of plastic that will produce this effect at home. You can, try some different materials out. But my question that I want to leave you with is, let's say we were to look at the ceiling lights in the classroom. Let me turn the light back on here. Give me just a second. And the question I would like you to think about is if you were to look at the ceiling lights in our classroom or your ceiling lights at home, and if you were to look at them through this sheet of plastic, what would you see? Would it look more like the last one you saw would look like one of the previous examples you saw, and we're going to talk about that in class.